Good afternoon, everyone. I'm Sofie Pelsmakers, and I've just started my second year at UCL. And I've been researching Victorian houses, and in particular suspended timber ground floors. And in the past, in my first year, I've mostly been looking at estimating heat loss through such floors. Why am I looking at ground floors? Basically, they're actually at the moment not very well characterized with current heat loss, but also how to best insulate them and reduce the heat loss, and what some of the unintended consequences may be. And those are the things that I will be looking at in my PhD, although I'll obviously just present some selected kind of findings. So most of the work that I did in my first year was based at Salford University in the Energy House. This is a plan of the, switching on would be good. This is a plan of the front room of the Energy House. These are basically a party wall, an internal wall, these are external walls and air bricks. And so what I'm presenting are three of the main findings. And the first one really shows you the variability and the large spread of heat loss across the floor. So for example, more internally, I have U values of about 0.56 and about twice that over in the bay near the external wall and these air bricks. The other thing that it shows, and I've got another graph as well to represent that, is that you can see that there's an increased heat loss along the perimeter, particularly here along the bay wall, and also here. These darker colors are meant to represent greater heat loss. And the fact that there's a large variation of heat loss across the floor, and also that there is these differences near the perimeter, has implications when you make comparisons to models. Virginia talked earlier about in-situ measuring and how we compare this to predictive models. And obviously that's very tricky, because with the floor, if we've got such different U values, how do you average this to compare this to a model whole floor U value? So these are some of the things I'm looking at, and at present we can't be sure that this is something that we can do with confidence. There's another reason as well, I'll get back to that as the third finding. Just a different graph showing the same issues before. These are the points taken within a meter of the perimeter wall, so the external wall. And what this shows you, and this is the rest of the floor, and this shows you that on average, the heat loss through near the perimeter is actually greater than the core of the floor. It's also considered to be statistically significant. And you might be wondering, why do I have no error margins on here? That's because I was working in a thermal lab, so I was pretty much measuring a steady state. And so I managed to take quite accurate measurements. So they are actually on here, but they're so small you can't see them. If this was in field, it would be 4 or 5%, and it would actually show up. So the second finding is that I did a controlled experiment whereby I closed the air bricks. So the ones here are open, the ones we just saw, and what you can see is that there's a 10 to 20% drop in heat loss when you actually reduce the ventilation through the floor void. It's like, again, it's sort of what theory tells you that would happen, so none of this is unexpected. But what is interesting is that we can actually measure this with in-situ measurements. And the other issue is, of course, you can also, so the greater drops are near the air bricks, again, what you expect. And there's also less variation when the air bricks are closed, so less variation in heat loss. And this is also statistically significant. So the difference between the heat loss when the air bricks are open or closed also matters statistically. And then the final finding really comes back to the method of in-situ measuring, particularly for floors, but I think it has probably implications for other fabric measurements as well. So what I also found is that depending on which room temperatures you take to define your in-situ U value, you get very different results. So for example, on the x-axis is the distance in the room from the floor. So this is pretty much my height. And if I take the room temperatures in the middle, this is in one variation in the Energy House, then I get U values of about 0.6, 0.65. If I take the floor surface, or say 100 mil up, it's about 0.9. So there's a huge difference depending on the method that you use. Now that has implications really for how we make comparisons to models. because the model assumes that there's no, basically that the air is very homogeneous, and it also has implications basically for making comparisons between different sources. So we need to be very transparent in how we undertake some of these measurements. And just one final note, if you take the floor surface temperature, then you need to adjust that as well with the surface resistance, which again drops your U value. And that's all there's time for today. Thank you.